So welcome to Drive System for Robotics Module 2 contents. In the Module 2 contents, we'll be discussing about the kinematics part of the robot. So in the kinematics part, what is forward kinematics, inverse kinematics, and the difference between the forward and inverse kinematics. So the kinematics of manipulator with 3 degrees of freedom. That is the first part. Further, it is a 4 degrees of freedom in 3 dimensions, deviation problems, control of robot manipulator, point-to-point and continuous path control. So all these things are discussed in the Module 2 contents of robot kinematics and control. So what is forward kinematics? Forward kinematics is the mathematical method used to compute the position orientations of the end effector of the robot manipulator using the known joint variables and the link parameters. So here, what are the input we give? It is with respect to the joint angles, joint displacement, position of. Further, the output, what we expect in the end effector is XYZ positions of the end effector. If you take the length, orientation of end effector must be the output. So the input and output with respect to forward kinematics, we are going to give input means we have to get the output from the robot. So like this, in the forward kinematics, we are going to consider these link parameters and the joint variables to get the required output. So if we take the 2 degree of freedom planar robot, if you consider the robot arm with 2 rotating joints, so the length of the first link is L1, link 2 is the length of the second link, theta 1 is the angle of joint 1, theta 2 is the angle of joint 2. So if you take the end effector position, x is equal to L1 into cos theta 1 plus L2 into cos theta 1 plus of theta 2. Similarly, if you want the y position, L1 into sin theta 1 plus L2 into sin theta 1 plus of sin theta 2. So the exact position what it gives, it is the xy in the robot's end effector. What are the steps we follow in the forward kinematics is identify the link length, determine the ankle joints or displacements, apply trigonometric or transformation matrix equation, calculate end effector position and orientation. Like this, the different type of steps it is used in the forward kinematics of the robot. So from the base of the robot, it is transferred to the link length, joint angles, end effector position and orientations we are going to calculate at each part, so that within the work volume the robot must be able to work. So in the inverse kinematics, it is the reverse part. So it must first it is going to reach the object. According to that, the other kinematics has been calculated and formulated. So the inverse kinematic, it is the mathematical method used to calculate joint parameters of the robot manipulator when the desired position and orientation of the end effector are given. So here the link length L1 and L2 are considered, XY are the desired position of the end effector position. We calculate the joint angle calculation, theta 1 and theta 2, which are supposed to calculate. Theta 1 and theta 2 it can be calculated by the equations which has been derived for the inverse kinematics. To reach the end point, that is XY position, here you are supposed to determine the angle joints needed to reach each point with respect to XY coordinates. So what is the difference between forward kinematics and inverse kinematics is, if you take the different features like input, output, complexity, number of solutions and use. So in forward kinematics, you have to calculate joint angles. In inverse kinematic, end effector position. If it is output, if we count position and orientation of the end effector, we count. In case of inverse kinematic, we will consider the joint angle. Forward kinematics, the level of complexity is simple in case of forward kinematics. And if we go with inverse kinematics, it is really complex, but reaching the endpoint, we have to calculate all the parameter to get the required motion inside the robot. So number of solutions in case of forward kinematics, it is only 1. In case of inverse kinematics, you will be able to get 1 multiple, or you may not get any answer also. What is the use of forward kinematics is simulation and position calculation. It is easy. If it is a inverse kinematics, robot motion planning has to be done. As we know that the number of solutions are multiple, robot motion planning has to be done. So as discussed in the previous slide, forward kinematics and inverse kinematics. So the xy equation suggests to calculate the position of the end effector. If it is inverse kinematics, you have to know the angular orientation reaching the xy position, theta 1 and theta 2 has to be calculated. So by doing the joint angles calculation, the end effector position it will be known. So by knowing the position, you'll be able to calculate the different angular joints in case of the forward kinematics. So the possible solution in case of a 2-degree freedom robot, there are two configurations. One is elbow up position, elbow down position. Another one is both can reach the same end effector point. This is the possible solution. So here the target point satisfies root of x square plus of y square is greater than L1 plus L2. The point is outside the workplace and no solution exists, means then root of x square plus of y square is equal to L1 plus L2 it comes. So what are the applications of 2-degree of freedom is pick and place robot, drawing robot, welding robot, educational robotic arms. Like this it can be extended.